Hi, today we're talking about dividing fractions and mixed numbers. That's Chapter 4, Section 6. If you aren't sure on multiplying fractions, probably should go back to 4.4, check out those notes, or multiplying the mixed numbers, that's Chapter 4, Section 5. Those videos will give you the basis that you need in order to do this additional step here in Section 6 where we're dividing. And really, division is just one extra step, so it's very doable. You can do it. First thing is, kind of assuming you copied down the title already, the real key is this one thing here, that when you're dividing a fraction, or dividing by a fraction, it's the same as multiplying by the reciprocal of the fraction. So dividing by a fraction is the same as multiplying, which is nice because multiplying is our easier one rather than addition or subtraction, as multiplying by the reciprocal of the fraction. In other words, if we're doing one fraction divided by another fraction, we're only doing the reciprocal of that second fraction, of the one in the denominator, so to speak. First of all, what is the reciprocal? The reciprocal, really you just flip the fraction. So that's pretty easy. So flip the fraction. So for example, I don't know if this is worth writing down, but say you have the fraction 3/4, the reciprocal of that is just going to be 4/3. This numerator becomes the denominator becomes the numerator. Alright, so if we go back and do some, I'm going to start with kind of two simpler fractions, and we'll get into the mixed numbers next. If I have 1/2 divided by 3/4. So first step, and what we do to change this back to a nice multiplication problem, is we take and we flip the 3/4. So if I have 1/2 times 4/3, and really you could skip ahead to the next example if you know what you're doing here, but just to kind of do that one more time. First, if you can do any reducing, that's going to make life easier later. So 2 and 4 are both divisible by 2, so I'm going to start by doing that. And now you just treat it like one big fraction. I have 1 times 2, or often I look at it as though you extend the line and make it one big fraction. So now I have a 1 times 2 is a 2, and then a 1 times 3 is 3. Make sure when you're multiplying that you cross that out. Well, I've seen a lot of people use that number when they do their multiplication. And we get a 2/3, which can't be simplified, can't be reduced anymore. If we go and do this with a mixed number, that just adds in one step. And like I said at the beginning, the mixed number, that's going to be the Chapter 4, Section 5 notes. You could check that out, or you probably could pick it up here. So if I have a 4 2/3 divided by 5/8. So we really want to do two things. One, we want to take and change this to a multiplication problem. So I'm going to say that's going to be 8 divided by 5. So it's 4 2/3 times 8/5. The other thing is we want to take this and change it into an improper fraction. So if I do that, I'd have 4 times 3 is 12, plus 2 gives me 14/3, and I believe doing that was in the Chapter 4, Section 3 notes, the Part 1. And now I can take and make this into one big fraction. So I'm going to do that. But before I multiply, I'm going to see, can I reduce anything, because that'd make life easier. And it looks like I can't, because 5 doesn't go into that, and 3 doesn't go into that, and there's 3 and 5 are both prime numbers. Okay, so then we just do the math. We have 14 times 8, which is kind of like 80 plus 32, so 112. Or you could go back and do math the old-fashioned way with 32, carry the 3, 8 plus 3 gives me 11. Okay, 112 in the numerator, over 15 in the denominator. And now we want to reduce that fraction there, or not really reduce. It is reduced. We want to take and change it back to a mixed number. So you could guess and check. That's one way that would work. Say, all right, so I'm going to do a 5 times, or 15 times 6. and see what that gives me. A lot of people could take and do that and say, okay, that's going to be 90, so then they know the answer is going to be 7. With that, the other way is to kind of do it the long way like this. And like I said, we saw that it was going to be a 7, or I did anyway, so we have 7 times 5 is 35, carry the 3, so now I have a 7 plus 3 is 105. So if I do a 7 up there, what I just found is this is going to be 7 in some number of 15ths, because I can have 15 go into 112 7 times evenly. And then from there, if we subtract, I end up getting a 7 here as well. So the remainder then, that when I pull a 7 out of here, when I do 7 multiples of 15 out of 112, I have 7 of the 112 left. So it would be 7/15 for a final answer. Alright, now for the last example we have. Now this one we'll be able to do a little bit more reducing. It won't be quite as beastly of a problem. 3 4/5 divided by 1 3/5. 3 4/5 divided by 1 3/5. So before I take and try to do the reciprocal here, we need to go and change it to an improper fraction, because the denominator of this 1 here is really 5/5. It's not 3/3. So you can't do the reciprocal until it's improper. So our first step then, I have 3 times 5 gives me 15 plus 4, so this is 19/5 divided by 5 times 1 is 5 plus 3 is 8/5. And we can't do any reducing yet because the numbers don't work. But if they did work, we can't reduce yet because it's not a multiplication problem. Instead, we need to say it's 19/5 times 5/8. And then hopefully right there it jumps out at you that, alright, I have a 5 in the numerator, 5 in the denominator. I can divide them both by 5. And once we're there, we can treat this like one ginormous fraction, with a 19 times 1, which is 19, over 1 times 8, which is 8. So our last step is just to take and change it back into a mixed number. So when we do that, we could say 8 goes into 19 twice. You'd have 8, 16, 24. 16 smaller than 19, 24 is too big. So when I put my 2 out in front, that's going to take 16 of these 19 out, which means that there's 3 left. So final answer would be 2 3/8. That's all from this section. Let me know if you have questions.